Hello and welcome to episode 5 of Look Up Tonight with the Orange County Astronomers. Our program tonight features highlights from the September meeting of the Orange County Astronomers at Chapman University. Chris Butler is our What's Up presenter, and he gives us a great summary of the objects of interest in the night sky in September and into October, as we begin to move into the winter constellations. Of particular note is how Chris makes a great connection between the naming of naval vessels and the names of constellations and stars. Our main speaker tonight is OCA Vice President Joel Harris. Joel is very well known for his passion for viewing solar eclipses. This time, Joel gives us a presentation about an even rarer event that is coming up in 2004. Did you know that no person living today has seen a Venusian transit? This happens when the planet Venus moves between the Earth and in front of the surface of the Sun. The last time this happened was over 120 years ago. Now on with the show and the What's Up presentation by Chris Butler.
Thank you very much. We will have here a whirlwind tour of the sky and a few of the things that I find interesting here. Let's indeed, actually, as you just saw in the next picture here, let's get on to Planet Roundup, some things going on there. Obviously, the public has been concerned that there is, of course, only one planet in the entire solar system, and that we only see it once every 600 billion years, right? We've seen the press coverage. If you're there in the back and you want to know what this means for you, of course, there will be dramatic changes in the Earth's crust as Mars moves away. The oceans are going to shift a little bit, and we will be underwater here shortly, so please just write a check to me and get to high ground, okay? Actually, no, it's not that big a deal. Things are kind of moving on with astronomy now. Actually, this is a video image of Mars that club member Roy Weinberger shot on a night when I was in attendance through also club member Bill Hall's 16-inch telescope. You can indeed still see Mars. It is still worth looking at. Bear in mind, this image was shot as far before the actual closest approach as we are now after, which is to say Mars is indeed still big. As a matter of fact, let's talk about that. Mars all the way at top left there, big as it was going to be for a very long time. You can see right now, September 15th, the next Mars. Hey, Mars is indeed still big. And then proceeding across to the right there, you can see Mars all the way through Halloween, how big it will look. It will still be pretty darn good size. And furthermore, you notice it's actually showing some phase, which is to say there's a dark bite taken out of the side of the planet. This is the only one of the outer planets we can ever really observe phase on, much at all. And about October 31st, that kind of a look for Mars, that's about how non-perfectly round it can get at that point. That's because it slipped to the side of the Earth-Sun line, so we're peeking a little bit over onto the dark side. If you get up early in the morning, you might see this. This is what I saw this morning when I got up. But after about 4 cups of coffee, I was able to actually see this. And which is to say the wintertime stars are with us again, as actually club member Bill Hall was pointing out to me. So I wanted to illustrate it again. If you're up before dawn, you will see constellations like Orion there with the 3 belt stars up at the upper right. Brilliant. Sirius, the bright star off at middle right, is in fact the brightest of all the nighttime stars. It's no illusion that these stars seem unusually cool and brilliant and nice. They are in fact the brightest collection of stars we in Southern California can ever see. So in the pre-dawn darkness, they seem to sparkle just all that much more. I also want to call your attention to just to the left of the top center, you have the yellow and blue star there. Those are the twins of Gemini. They have a guest with them, which is to say the planet Saturn is in the morning sky right now. It reemerged from going back behind the sun. It was a little scorched. Parts of the planet have been blackened, but otherwise, I love the fact that college students are writing this down. This is not the part of the show you want to write down, guys. I'll pull your leg a lot, all right? I came here as a college student, first time myself. Saturn is right in the middle of that pattern. It's brighter than the other stars of Gemini. You really can't miss it. Of course, you could set up a telescope to see it not as a star, but as the ring planet. The rings are wide open. If you're up at ODark 30 and set up your telescope, you've officially gone around the bend in this hobby, all right? I'm not going to do that. Jupiter, however, has also reemerged. and it is brilliant low in the east just before the sun comes up. Looking at the constellations, the way to see them when it first gets dark, first of all, if you're in the city, you don't see that glowing band of smog. That's called the Milky Way, straight overhead, foretold to us by the stories of the ancient people who lived before we had city lights. But you do have the triangle of bright stars of Vega, Deneb, and Altair marking the summer triangle. They're still very much with us. Down the south, at the bottom of the picture, we really have one star out all by itself. That's Fomalhaut, or Fomalhaut. Connections between the ocean and the stars I like a lot because, of course, I'm a ship fan. One thing I did find, talking about our own Navy, you may think there's no connection stars to the Navy, apart from Tom Cruise, who was in Top Gun and all that. The actual connection, though, that led me to look into this, my uncle, my great-uncle, was on the battleship California. Before that, he was on the USS Procyon. And I know that, yes, seriously, Procyon. And I know this because I have his photo album book from the Navy from 1919, leather-bound. And I thought, Procyon, that's been sticking in the back of my head. I'm going, I wonder if any of the other ones were ever named for stars. It was an old training ship. I've heard about it in other stories. Lots of the World War II admirals served on the Procyon. It so happens that our Navy has quite a tradition for naming ships after constellations and stars. And in this particular view right here, you might be surprised to learn that these oceanic types of constellations down in here have received all of these naval vessels. And this is only the start. These are obscure dang stars. These sailors had to repeat that name 5 times in the karaoke bar in Singapore to get the girl to know what ship he was on. Seriously. And look all the way over there at upper left, the USS Pleiades. Who would ever have thought? And not only that, I think about 4 or 5 of the individual stars in the Pleiades cluster got a USS. This was a huge shock to me. Most of these are armed cargo ships, by the way. That's traditionally what they did. So the USS Sagittarius, Altair. My favorite really has got to be the USS Markab. Remember I've told you in prior years that star of Pegasus? Do you know what that name means in Arabic? Boat. It's the USS Boat. That's great. So I do think this is kind of unusual and interesting, and I wanted to pass it on to you. By the way, just so you also know, they have mission patches for ships as well. And for those of you who are purists and astronomers, if you don't think sailors know the stars, look at the patch for the USS Aquila down there. That is a bang-on representation of a constellation that's out tonight. So this thoroughly weird connection between the ships and the stars has gone on even today. And yes, there was the USS Mars. There are presently 9 ships in commission named after celestial objects in our Navy, by the way. Weird detour, sorry about that. For the hardcore astronomy stuff, let's face it, it's dots and lines time, folks. You do have constellation of Pegasus, the upside-down wingless, legless flying horse, with the great square, which is almost straight up right now, marking its body, and the head goes out upside down, drawn to the south, to Enif, which is his nose. The globular cluster M2, beautiful spilled salt-looking cluster of millions of stars in a ball or globular shape, that's why they call it a globular, is right off Aquarius. Now remember that Mars is in the bottom of Aquarius. If you're down there exploring, please do have a look at M2 because it's in the fall sky. The stars are a little bit fainter. Often it is ignored. And that Y shape of the water jar, you may be asking, why is it water-shaped? Why not is the answer. I don't know. Down at the bottom, we have the Helix Nebula, one of the largest, most photographed and famous gas clouds blown off by a dying sun. That's right, it's pretty when someone else's sun dies. This thing is actually almost about half as big as our moon in the sky. It's huge. You'd think it'd be easier to see. Far from it. As a matter of fact, the Saturn Nebula, another example of those, which actually the smoke rings kind of do look like Saturn. In that case, the Saturn Nebula much farther away, much fainter overall, but the brightness, because we're seeing it at a distance, is compressed into a small point. The Saturn Nebula, easy to find. Helix Nebula is a rumor from Orange County, okay? And lastly, there are some other objects in that area that I won't delay on. For the guys with the big telescopes who've gone ahead and gone through the divorce because you bought the telescope, let me work you through the process of something to do with your lonesome time, all right? By the time the football game has gone off the air, may I suggest you direct your attention south to the USS Fomalhaut and that general area of the sky. Right over the horizon is an unusual constellation far south. The brightest star of it is Alnair. This is Grus the Crane. Grus's brightest star there only rises 9.5 degrees above our horizon. It just barely comes up and goes back down. Thus, even if you've observed the stars for many years, you may not have seen this southern constellation. It does have a distinctive form, looks kind of like a Greek letter lambda a little bit, more than really the cross, the way it's drawn here. But the reason I direct your attention to it, if you have big telescopes, this is one of the prime galaxy hunting spots for the Aussies, the Kiwis, and the Boertrekkers or whoever down in South Africa. So if you want to play around, these exotic and bizarre galaxies that are not very high, they're faint, they're hard to find from this latitude on Earth, these will be your special friends, okay, during your quiet time. For the meantime, I advise you to keep your eyes to the skies wide open, and with a mind that has done push-ups with astronomy books, you know you'll have no trouble spotting what's up. Thank you very much for your time and attention.
Doesn't Chris do such a great presentation? You gotta love him. Now we get on to highlights from the main presentation by OCA VP Joel Harris on the Venus transit in 2004.
Actually, yeah, what I'd like to do, Barb and I were talking about this beforehand, I'd like to start off by showing the video. There's actually a video now. Let me not sort of get you off your feed. This is a video not, of course, of a Venusian transit, and I'll talk about why it can't possibly be that, but this is of the Mercurial transit this past May. Pretty interesting stuff. Like Venusian transits, so Mercurial transits take approximately, a little bit less, about 5.5 hours to occur. But remember, of course, Mercury subtends an extremely small sized angular diameter. Venus is somewhat larger. But those who are going to be fortunate enough to go see the Venusian transit next year will see something similar to this, but again, a larger black dot. And I know people are going, how can you get excited about this? I mean, certainly a solar eclipse. A solar eclipse is pretty dramatic. This is sort of like watching paint dry in a lot of ways. So what's the big deal? And in a way, I think, thank you, Barbara, that's a really excellent lead-in. I wanted to show this to begin with, maybe to give people a little flavor. What is all the fuss about, once again, seeing in this case now a somewhat larger black dot march its way across the sun for 5.5 or 6 hours? Okay, well, once again, my talk, as Barbara said, the reason these are such a big deal, at least in this case next June, that a large kind of a hubbub is occurring in terms of this Venusian transit is these are truly rare events. It's funny, people say to me, well, solar eclipses are pretty rare. Sure, they are for any one place on the Earth. It's about 300 years if you just stand in one place or one locale and say, I'm not moving, I'm waiting for the eclipse to come to me. You've got a long wait. It's typically about 300 or so years. Well, other than that, though, as things go celestially, solar eclipses actually are not that rare. They occur every, about 18 to 24 months. Now, they aren't always total eclipses. Sometimes they're partials. Sometimes they're special partials called annular eclipses. They're still a central eclipse, but you don't see the corona. And again, they are not eclipses that are full in that sense. But truly, transits of Venus are very, very rare events. And again, the last one occurred specifically in the year 1882, about 121 years ago. So if we see the next, if you punch it again, basically this is saying there is no one, ladies and gentlemen, alive today, no one on this planet that has seen one of these events. That's how rare it is. And we're very fortunate because we happen to be living at a time now where we're going to get to see one of these events with some effort. And again, there are various places that people can go. The point is that it is something pretty rare. This will be the first transit also, of course, since modern photographic and telescopic equipment has been available generally to not only lay people, but of course professionals as well. So this is pretty exciting because once again, in 120 some odd years, the state of the art as far as both photography still and, if you will, video or moving pictures, as well as visually observing or using other kinds of optics has really changed. The face of astronomy, especially optical astronomy, has just dramatically shifted in that 120 years. Again, these occur about 120 years apart. Venusian transits occur in pairs because of the orbital mechanics involved, and again because of the relative positions of Venus and the Earth and the Sun. They're separated by a period of 8 years, so if you do the math very quickly, of course you know there's one next year. There will indeed be another transit of Venus 8 years hence in the year 2012. It'll be slightly different in terms of its area of visibility, but nonetheless that will be the second half of this current pair, or about to be current pair of Venusian transits. The infrequency, among other things, is due to the fact that the orbit of Venus is tilted, it's inclined, about 3 degrees, actually 3.7 degrees, to the ecliptic, the path of the ecliptic, which you heard Chris Butler talk about a few minutes ago. That's one of the big reasons that there's an infrequency in terms of these events. Now, you know, mercurial transits, yes, they occur a little bit, in fact, quite a bit more frequently, about every 10 or 12 years. As I said, we just had one this past May. There was also one about 11 years before then. The fact is, one of the reasons mercurial transits are more common is Mercury is a lot closer to the Sun than Venus. Its orbit is also slightly out of the ecliptic, but because it is so close to the Sun, something like about 29 or 30 million miles away, even though it's very diminutive, it certainly is something that crosses the disk of the Sun quite a bit more often in that sense. So seeing a mercurial transit, there's probably a lot of people in this room that have seen one, but again, Venusian transits are really rare. Some past transit highlights. First kind of transit, or first transit, excuse me, observed by anybody, either Venusian or mercurial of an inner planet, obviously one of those two planets, was actually seen back in 1631 by Gassendi. He was a fairly well-known French astronomer and very interesting fellow. In fact, again, he was very intent on seeing this. And people knew that certainly, again, among other things, Kepler and other people of his ilk had predicted that transits were possible, and indeed they could happen. But of course, remember back the state of mathematics, even though it was fairly well developed, predictability of celestial events, especially transits, eclipses, things like that, especially transits, were so rare that it was pretty tough to really nail down exactly what date in 1631. They knew about what month or what week, but they couldn't nail it down much better than that. Again, it's interesting. Gassendi used an image, basically the old classic, what to us today is classic methodology of an eyepiece type projection through his refracting telescope that he had. He actually used it to refract the image and project the image into a darkened room that he was observing in Paris onto a wall where he had a white screen. So he could hopefully observe the passage of Mercury as it moved across the Sun, even though, once again, as you just saw, it's a really small dot. So you have to be pretty observant, even though it takes a while. Anyhow, he used a 10-inch diameter scope to do this, or an image, I'm sorry, they projected against this screen, and he traced the image of the Sun, of its circumference, and the various positions of Mercury on the screen. But there was a problem. The house that Gassendi was in was a two-story affair. And while he was able to project the image of the Sun successfully using, among other things, a coelostat to project the image into his horizontal refracting scope onto the wall, he had to have an assistant who would help him with timings. What exactly was so important about this? He had to have fairly good timings, at least as far as the various altitudes of the Sun and the progress of the transit. So since his assistant was upstairs, making sure that, again, they weren't losing their track of the Sun, and Gassendi was downstairs, and of course they didn't have wireless, they didn't have phones, they didn't have cell phones, they didn't have anything else. How does he tell his assistant that it's time to make another timing? He would sit there in his first floor there and stomp his foot every time he wanted his assistant to do this. Well, the problem was the assistant wasn't particularly interested in this. This wasn't too fascinating. Remember I said transits are not dramatic. It doesn't get dark. The temperature doesn't go down. You don't hear birds and animals acting strangely. So his assistant got a little bored. By the way, just another little sidebar here. They weren't able to predict, if you remember what I said, this transit occurring specifically on a particular day or even a particular hour. So Gassendi was so concerned about Kepler's predictions, he started watching or looking for the transit 3 days ahead of when it occurred. That's probably another reason why his assistant got a little bored. Anyway, the assistant, as I said, nonetheless, kind of took a powder for about 5 or 4 hours of that day that the transit actually did occur, and Gassendi was kind of yelling around trying to get people to find him. They finally found the guy. I guess he was down the street having a cappuccino or something. They grabbed him, brought him back, and was able to, again, get some timings on that transit. So it did work. He did get some data recorded, but it was crude at best because you have this guy and you're stomping your foot trying to get the guy's attention. Anyhow, moving on with the next point. The transit, again, in this specific case, transit of Venus, in 1639 was observed. The two astronomers in Great Britain got so excited when they saw the transit occurring, because they knew it hadn't happened in quite a while, they actually forgot to do their timings of the ingress of Venus into the sun's disk or onto the sun's disk and the egress as it left. So they got so excited that they forgot to do their timings. That's something certainly I'm very familiar with at eclipses. There was a time a number of years ago where I got so busy telling people about what they were going to see at a central eclipse or an annular eclipse over in Morocco. A busload of, or a couple carloads of Europeans were there asking me what I was doing. I got so excited, I forgot to put film in my camera, and the rest is history, as they say. So obviously, while that sounds funny and pretty stupid, the fact is anybody can get excited or get really focused and they forget about what they're doing. So unfortunately, these two individuals didn't get their timings down. Caused some problems. They weren't able to get useful data. Next view graph, if we can. This is an interesting transit drawing by the famous Captain James Cook. He also was very involved in a transit that occurred actually in 1769. He went to the island of Tahiti in the South Pacific, and I'll talk about that in a couple of minutes. Kind of interesting. You'll notice, by the way, especially if you'll see about the fourth or so image up from the bottom half of this drawing that Cook made, and the second image that you see from the bottom on the upper half, you'll see what appears to be sort of like a hanging area there of darkness outside of Venus's circumference or outside of its disk. This is what's known as the famous teardrop or black drop effect. And again, the problem with this, when you want to get accurate timings of Venus to figure out what we call the solar parallax, to be able to do that calculation, figure out the distance we are from the sun, and I'll talk about that, as I say, in a few brief moments. The problem is you've got to, according to Edmund Halley, who did a lot of thinking and predicting about how useful seeing a transit of Venus would be in finding out our distance from the sun. The problem is, Halley said, you really need to get this timing down to about 2 seconds worth of accuracy. Well, when you've got that black teardrop hanging on the edge or the disk or the limb of the sun, it's going to make it pretty difficult. And others in subsequent eclipses from 1769, the eclipses, or I'm sorry, no, eclipses transits in both 1882 and also in 1874 saw that same phenomenon of the black drop effect. So it's tough. Now, what will be interesting this time, next June, will be, will we see that effect? Or is that some anomaly, if you will, caused by the optics that were in use at the time? Or is it truly an atmospheric anomaly or something else? We're not sure, but it'll be kind of fascinating to see if people see that on digital video, when they start processing it. Does it go away? You know, if you use the old, basically emulsion type film, what are we going to see when people start recording this next June? Is there going to be a black drop effect? Yes or no? For the transit of 2004, visibility will mostly be in the Earth's eastern hemisphere. It really won't be terribly visible here. At least the whole event will not be visible here. This gives you a good idea. This was courtesy of my colleague Fred Espenak over at Goddard Space Flight Center in Maryland. This is a map showing you, of course, where various parts of the transit are visible. Everywhere within that white area, the entire transit from the beginning, from the encroachment onto the sun, through going across or marching across the sun like you saw Mercury do a little while ago, and then the exit or egress will be visible in those areas. And at very, very high northern latitudes, indeed, even way far to the west of the eastern hemisphere, that region around, again, the Mideast being almost directly overhead at local noon, you can see the entire transit. Otherwise, if you're in that light gray area, you're only going to see part of the transit. For instance, in Australia, in Indonesia, South America, parts of the eastern or even central United States, yes, you'll see the transit, but you won't see the whole thing. You'll see it as it's progressed at some point. You will see the exit, the third contact, where one side of Venus is beginning to make its way off the solar disk, and then fourth contact, where the black drop effect occurs, possibly at that point, at that demarcation. And of course, where the dark gray areas, there's no transit visible at all. You're out of luck, that's the end of it, game over. So those are the places where people can see this. Well, I think if that's what I think it is, just let me give you some data in case people are curious and want to learn more about this transit and transits in general. Here are some excellent URLs, some sites that you can get some data from. Transit of Venus.org has some wonderful stuff. In fact, a lot of my talks, some of the material I got tonight, was a result of some articles on there by, among other things, Stephen Dick from U.S. Naval Observatory. Sun Earth GSFC, that's Fred Espinak's eclipse/transit URL, his website. Some wonderful information. That map you just saw is there. So it's a good place, several places to start in terms of that. And I think with that, this probably is what wraps up.
Thanks, Joel, for such an interesting talk on this rare event. I'm certainly going to look forward to it. I hope you are too. Thanks for watching, and I hope we'll see you next time. The close approach of Mars created an amazing public thirst for seeing Mars through a telescope. The OCA was involved with several special outreach events, including one at the University of Irvine Observatory, where we had an estimated 10,000 people attend. You are looking at some of the crowds attending that event, and also an event at Irvine Valley College.
Oh wow! Maybe it changed. You can totally see the polar path. That's cool.
Right. Looks like a ball.